Last time I showed you a trick for using an Allen wrench to remove the propeller. I went on a forum and someone mentioned to me that there was a prop wrench that came with the Phantom, so I thought I would show you how that works instead of using an Allen wrench. The advantages are that you're not shoving something into the motor windings, I guess, or near the motor windings, so perhaps it's a little bit safer. So in my example, it doesn't fit very well. Like, you would expect it to just slide right in, but that doesn't work. So I just kind of push it down and then I can turn my prop one way or the other. I mean, it does seem to work pretty well. So there's an example of using the prop wrench. This wire was attached right here, and all three of these wires were bound together with this zip tie. You can see them back here on this one, and there's another zip tie over here. It's just like that. So it just binds these three wires together so that they don't move during flight. And the way I cut it is I just took wire strippers and I pushed them up against this black part and just snipped it. Pretty simple. The next step is I'm going to unsolder these two leads here on the board. I'm going to use this desoldering wick to do that. So this is something that I picked up at Amazon. It's supposed to be a really good brand. High reviews. I'd like to talk a little bit about soldering iron tips. I'm no expert, but I did a little bit of research before I did this project. So this is the original tip that came with my Wiho 888D. And as you can see, it's a chisel tip. It's not a point, and that's good. But it's small. It's designed for very small components. In comparison, I ordered a slightly larger chisel tip from Amazon that's also for this soldering iron. It's a little bit broader, and people say that they like it better for most integrated circuit work. So we're going to give it a try today, and we're going to see if it regulates the temperature better and stays hot longer and, you know, generally works. Okay, we're going to desolder these two leads now. I've set my Wiho 888D to 450 degrees Fahrenheit. I don't know if that's going to work really well. I just reset it to factory defaults because I think I messed up the temperature setting. So we'll see. If it doesn't work, we'll raise the temperature. I'm going to do this left-handed. I'm going to hold the wick in my right hand and the soldering iron in my left for the camera. That's not normally how I would do it. So yeah, it might slow me down or make me a little shaky. I apologize. From the videos that I've watched, I think all you do is you take the wick, you put it down over top of the joint that you want to desolder, and then you touch the soldering iron to the wick and the joints. And the wick has flux in it, which cleans things as you go, and it should just absorb the solder. Nothing's happening, so I'm going to increase the temperature. So we tried 450 degrees. We're going to try 500 degrees now. Still not going fast enough for me, so I'm going to go up to 600 degrees. Okay, we're at 650 degrees now. I can actually feel some heat coming through the wick this time around. I see some solder on the wick, so I think I'm doing a good job. It's still not going very quickly though. I'll try 750 degrees. All right, desoldering now with a wick at 750 degrees. Still not hot enough, I think. We're gonna go to 800. 850 degrees. We'll see if this works. There we go. Yeah, that's what you want. I can feel that heat. Seems okay. Still isn't coming off though. Really want to go any higher than 850 degrees. It seems like a bad idea. I think I'm going to switch to using a desoldering pump. This is just taking too long. This is my pump. I showed it in a previous video. It's just got a little button. You push the button, sucks up the solder. Works on a vacuum system. So all I'm going to do is melt it and then suck it. Melt it and suck it. There we go. That worked. So there you go. Use a desoldering pump. I think the braid works really well in certain situations, the wick, but didn't work too well for me in this situation. The desoldering pump seems to work better. There may be I'm sure there's a science to that. I'm sure there's a reason why one works better than the other, but we'll just continue using the soldering pump for now. I don't know what this type of soldering is called. Surface mount, maybe? It's not through hole. I know that. So at this point, we've got the wire detached, and I'm just cleaning up the pad. That did not work. There we go. So now I think we're ready to remove the screws. They're a little hard to see. This is the ESC board. ESC stands for Electronic Speed Control. I've been told that this is the newer version of the board. I'm not sure if I got the newer version of the board as a replacement, but they look identical to me, so I think we'll be okay. This has the LEDs on the back as well, which I don't know why you'd want the LEDs on the motor speed control board. That seems kind of silly, but whatever. Good cost, good weight savings, I guess. So we need to remove these screws next. So we're gonna remove this screw here, and then we're gonna remove this screw, and that'll free up the board so that we can remove the board itself. And the motor is still attached to the board, so once we've got the board removed, put it into some helping hands to remove the solder and the motor. So the motor that's attached to the ESC board right now is the old version of the motor. I've heard that the motor that I had originally on here is more performant, higher power or something. As an experiment, we're going to leave the old version of the motor on the ESC. We're going to desolder it and then resolder it to the new ESC and see if the Phantom flies. However, I have an email out to DJI tech support, and they'll give us the definitive word as to whether we have to use this kind or not, in which case I'll have to find a supplier for these because I bought these on Amazon and, you know, they didn't have this kind. Okay. All right, so now I'm just gonna unscrew these little screws here. Similar to the screwdriver situation, I realized that the Phantom 2 actually comes with a screwdriver, a Phillips head screwdriver for this size of screw. However, I've got a couple of my own, so I don't really need theirs. But it is nice that they give you one. It would be really nice if instead of an Allen key, if they gave you a screwdriver with an Allen head on it. I bought one of those on Amazon, but it hasn't arrived yet. It's I believe it's a Wiho brand, which seems to be really popular with the industrial crowd. Okay. These tweezers are Wiho tweezers. They've got electrostatic discharge protection built in. It's like some sort of a, yeah, see that? Wiho. Germany. Some sort of a coating there. So there's our board removed, pretty simple. Let's just give it a good look. Make sure that it's the same. Yeah, it looks identical to me. Pretty sure that's the same board. This is just a cheap pair of helping hands. I'm pretty sure I got this at Radio Shack years back. No big deal here. These are just handy instead of a vise or something to hold your workpiece while you're desoldering or soldering or whatever. So I moved my camera so that I can have a right angle or a right hand grip, and that should help quite a bit. Okay, same thing here, just touch, let it melt, suck it up. So this is the only thing about these soldering pumps. I just ejected this core of solder from inside the pump. When you use them a lot, they get clogged up and it can become difficult to clean and they don't work very well. I don't know, I'm starting to think that the right hand grip is actually ideal here because my right hand is stronger and this pump takes a lot of strength to operate. Who knows? So we're all done with that board. Just release it from the helping hands and put the next one in. We'll do the same thing with it, except we'll solder. So yeah, should be easier. All right, there we go. Now the order here, I'm looking at one of the other motors. Actually, I'm looking at the motor on the other side because the order is different for the different motors. So the order here is, this one is red. These are black motors, not silver motors. So the order is red, yellow, black, and that is the order that we will use. On the silver motors, the order is yellow, red, black. So red, yellow, black is what we're going to use. I'm going to tin my tip because it's starting to look a little dingy. Wouldn't normally do that over the component board, but want to do it on camera, I guess. Now I'm using a very thin solder here. I'm not sure if this is appropriate. I bought this because this is what people on YouTube recommended for doing board soldering work, but these wires are fairly large, So I kind of wonder if I should be using a larger solder. We'll give it a try. So what I did is I just moved the motor around until, and I bent the wire until it kind of stayed in place. We'll see if that works. Hopefully it does. This should be the pad with the least amount of risk because it's furthest away from all the components. This one will be the one that I have to be careful on. So this is the C pad currently. And my tin looks dingy already. What is going on? Stuff burns off way faster than my other solder. It's messed up. Okay, so my understanding is that you heat the pad and the wire, and then you touch the solder to both. We'll see how that works. Seems to work okay. I don't really know how much to put on there, but that looks all right for now. So red, yellow, black. Next one is yellow. We just want to make sure that we don't heat up the board too much as we're doing this. Okay, we're ready for the next wire. Same thing. Touch the solder to the wire, touch the iron to the wire and the pad. It should just flow on. There we go. Man, I have to re-tin this tip every 5 seconds or it gets dirty. This solder must burn off really fast at 850. Not real happy about that. I'm going to change my temperature a little bit. Maybe the solder that I'm using is a lower temperature solder. Lower it down to 650 and see if that helps. I'm gonna ruin my brand new tip if I keep going this way. Okay, final wire. Well, that might not be the prettiest work in the world, but I think it'll do. It'll do, pig. So I've reinstalled the screws in the ESC and I've reinstalled the screws in the motor so that there's no tension on the wires. And now I'm just going to take this little wire here and position it so that it touches the pads and then solder it back onto the pads. I can't really say back on because this is the first time that this particular one will have touched the pads. It's a new part. This may be a bit of a challenge. And I really want to get both of them touching before I start soldering because it's going to be much more difficult to rearrange after one of them is already soldered down. That would probably be fine. I might be overthinking this. Okay, I'm just going to give that a shot. That seems like it's good enough. The solder that was on here before melted at 850 degrees. It seemed like a really high temperature solder. The solder that I'm using right now is called Kester 0.80 millimeter rosin core. It's a number 66/44. It seems to melt at a much lower temperature. When I raised the temperature to 850 degrees, started corroding my soldering iron tip after just a couple of seconds of being in the dock. When I lowered the temperature back down to 650 degrees, this stuff melts just fine at 650 degrees and my soldering iron is not corroding anywhere near as fast. So I definitely think that you need to run this particular solder at a much lower temperature. Okay, so same deal here, just touching the pad and the wire and touching the solder to it. There we go. And same thing for the other one, but this time I'm going to push the soldering iron down on top of it because I want it to actually contact the pad. That's not going to work. There we go. Again, that old solder that was on there was just really strong stuff, high temperature. It lifted up off the board. I have to find a way to push it back down. I'm going to have to desolder this one. I really want that pad touching before I solder. Otherwise it's going to lift up and I'm going to lose my connection as the solder cools. So it wanted to lift up at the end there, but what I did is I just used my finger to hold it down, and it was very hot. I almost got burned, but I didn't. Hopefully that'll be a satisfactory connection. So let's test this bad boy, see if it fires up. Installing the battery now. Turning it on. Ah, I forgot one of the wires. I actually forgot more than one wire. First wire that I forgot is that little guy right there. Okay, he's reconnected. Second wire is the antenna. And the antenna is this guy right here, so part of the top. So I'm just gonna push that in. Okay. And I'm gonna rest the top I'm going to rest the top on top of the motors here, as long as it'll let me. There we go. Okay, let's try that again. Turn it on and start up the motors. Oh, that's a beautiful thing. Sweet. All right, I'm going to turn it off and I'm going to reinstall all of the propellers and the screws for the body housing, and then we'll take it outside and we'll give it a test flight. All right, here we go, moment of truth. Let's see if she flies. So the moral of the story here is don't crash, but if you do, it's not that big of a deal. Just get a soldering iron and you can fix it. But you'll pay for the parts. See you, YouTube. Happy flying.